Hello, everybody, and welcome back to the Barnyard Broadcast. I am your host, Maddie Horkler, and today we're going to talk a little bit about small ruminant parasites. I have three guests with me today: Dr. Scott Bowdridge, Mrs. Melanie Barkley, and Dr. Robert Van Son. Without further ado, let's get into today's conversation. All right. Good morning, everybody. Welcome to the Barnyard Broadcast. We're going to get started here. We'd like to give some short introductions. Obviously, I am Maddie Horkler. I'm the host. Melanie, if you would like to give a short introduction first.
Good morning. Melanie Barkley. I am a livestock educator. I work out of the Bedford County office. I've been in Bedford for almost 32 years, and I have about 30 years of experience raising sheep.
All right. Dr. Van Son, do you want to go?
Sure. Thank you. Good morning, everyone. This is Dr. Bob Van Son. I'm an extension veterinarian and professor at Penn State University. Been at the university since 2000. Prior to that, was on the West Coast, working at the University at Oregon State, and then had clinical practice prior to that, and have been teaching parasitology for the past 25 years.
Sweet. Thank you. Dr. Berg, do you want to go now?
My name is Scott Bowdridge. I'm a professor and livestock extension specialist at West Virginia University. My primary area of research is in parasite immunology and understand the genetics and immune response in sheep to parasites.
Sweet. Perfect. So we're just going to get started right here with the questions. In your opinion, what is the most effective way to identify a parasite problem?
I think we need to start with several things that we want to look at. So if we're looking at FAMACHA scores, if we want to look at the jaw and make sure we don't have bottle jaw, we want to make sure the sheep are not losing weight, make sure there's no diarrhea, and we can also check the nose to make sure they don't have any nose spots that's happening there. So it'd be kind of a 5-point check so that they don't look at just specifically one thing. I think they need to have a all-around approach and look at different items or different characteristics within the sheep that show that they may have internal parasites.
I would go ahead and reinforce what Melanie had said and just add to that fecal egg counts certainly need to be in the diagnostics. We know there are limitations to fecal egg counts. We know that there are some limitations to the FAMACHA scoring because it's specific to hemonchus, things like that. But the DEG, the 5-point animal evaluation system is probably our best way.
So we're talking a little bit more about parasite and parasite management specifically for producers. So if you could tell producers one thing about parasites or parasite management, what would it be?
I'll start off and hope that Scott and Melanie will move in. I'll just reflect the age that I am at this point and talk about when I was in vet school in the 70s, we were taught that drugs was the way to treat parasites. Just use anthelmintics and use it frequently, and parasites we have a zero tolerance for. That's unfortunately put us in the position that we're in today, in that we have all this anthelmintic resistance. And so I think we really need to be thinking about broad-based holistic approaches and have the mindset that zero tolerance of parasites is just not an acceptable or viable practice at this point. And we just need to focus on good selection and minimizing the risks, knowing the life cycle, and intervening where we can to try and minimize the clinical aspects here.
I think to add to that, not only with selection, I think people need to pay attention to culling practices so that they identify those hoarders, I guess, within the flock that have all the parasites that they're shedding and sharing with the others.
Yeah, that's typically what we call the 15-85% rule or 20-80% rule, depending on who you listen to. Basically it says that the majority of the parasites in a flock or a herd are accounted for by about 15 to 20% of the animals. So as Melanie said, if we can identify those that are basically parasite hotels for everybody else, we need to get rid of those.
And with that selection, I think the National Sheep Improvement Program has a great opportunity for producers to select sheep that have that genetic resistance with those fecal egg counts. And I think Scott's done some great work on the genetics of sheep and managing those internal parasites.
Well, so the great thing about the NSIP program is that it's not only limited to a single breed. So you can have Suffolk sheep with parasite resistance breeding values, or polypays, or targies, or Dorsets. It doesn't always have to come back to it being a hair sheep or being focused on Katahdins. So I think that there's a large value in selection for kind of a long-term approach to managing this. I also think that we probably expect a little bit more of our pastures than they're actually giving us, or what the sheep are actually taking. So there's a nutritional component to all of this as well. And I hear a lot of people say, well, my sheep run on grass and that's all they need. Well, if they've got parasite problems, then that's not all they need. Also thinking about some strategic supplementation, particularly with protein supplements. Stuff that we've done in the past have found that those things have a marked improvement when you start dealing with parasites.
I'm really glad you mentioned that, Scott, because that is really the area that I try to focus on. I think, good nutrition is really the cornerstone of keeping animals healthy, and some of the work that you've done and others target feeding some additional metabolizable protein in late pregnancy, not allowing these girls to mobilize body tissue in mid-gestation, in other words, underfeeding them too much, as well as some of the work that we're doing now clinically. There's certain parts of Southwest Pennsylvania and other areas in the country where we're seeing challenges with copper deficiency and as well as selenium deficiency, of course, but those are going to have some impact on the animal's ability to manage and deal with the parasites.
I think one thing I notice as I travel around the state related to nutrition is their pasture management practices. So we definitely want to make sure that producers are not overgrazing so that those sheep are down in that lower 1 to 2 inches and picking up, ingesting those internal parasite larvae. So I think it's important that they do a good job of subdividing fields and maintaining at least a 4-inch height on those forages.
Absolutely. I know that Dr. Van Son talked a little bit about dewormer or resistance. So what, in your mind, is a good way that producers can reduce the amount of dewormer resistance in their flock? Just at home, some easy things for them to change in their program or what have you.
Well, I'll start. The first thing, of course, is just to reduce the number of deworming treatments and target treatment. So that's where some of the things that Melanie talked about, like the FAMACHA scoring, identifying those animals that are clinical, those are the ones you want to target, treat. And then the biggest thing that we have, the challenge that we have, especially in our small ruminants, is everybody treats the same dosage. They have the average body weight of their animal, and really, as any medicine is administered, it needs to be administered at an appropriate dosage per unit of body weight. And so it would be best for flocks and herds to consider the purchase of scales and be able to use scales to properly dose the anthelmintics.
That's certainly something that has contributed to the development of resistance with this. I think we've got some new technology that's come out in the last few years where we've got dosing guns that Bluetooth the scale heads, and they can automatically change the dose per individual. So instead of moving the screw at the bottom of the drench gun or getting a different drench gun or doing those kind of things, there's some technology out there to help with solving that. I think the biggest thing, and we talk about this a lot with our American Consortium for Small Ruminant Parasite Control, and on our website, wormex.info, I have a lot of information about how to dose, which anthelmintics to use, and how do we think about anthelmintic usage going forward. So I think, like Dr. Von Son talked about going back in the past, 15 years ago, we would talk about rotating dewormers. And we don't talk about that anymore. And so we're trying to tell people to stick with one dewormer until it doesn't work. Right. So then that way what the genotype or what the parasite population that you have in your flock and on your farm, what they are susceptible or resistant to, right? And staying with that. The other thing is to think about using combination deworming. So I don't mean mixing dewormers together and giving them to them. It's giving them 3 different dewormers. And what you get with that is actually a more efficacious dose. So let's say that you're going to use ivermectin, and ivermectin works on 50% of the worms. Well, the other 50% may have some susceptibility to a benzimidazole like Valvazin or Safeguard. So you use that, and then that's only effective on 20% of those 50%. Then the other 30% are susceptible to prohibit. So then what you get by combining all those together is if you've killed 96 to 99% of the worm population that are there, and the more of them that you're effective at killing, the fewer of them that are surviving and contributing to the genetics of the next generation. So you have to be kind of a little bit of a worm farmer with this and think about that every time you deworm your sheep, you're culling parasites that are susceptible to the dewormer. So it's negative selection, and you've got to keep that in the back of your head. So every time you're doing that, you're changing the worm population ever so slightly. So the fewer times that we can use dewormers, the better.
Absolutely. And I know you two have been kind of going back and forth, and it's Melanie as well, talking about, how things were, and now how we have gotten to some of the advancements that we have made today. Would you guys just elaborate a little bit on some of the innovations and advancements that you've seen in parasite management or parasites since you started working on them, or just in industry and such?
I think the adoption of FAMACHA has really helped promote people not deworming everybody and then retaining that refugia or the parasites on the farm that are still susceptible to those deworming products. I think the other thing is kind of very interesting to me was the bioarma with Livamol, where they're putting in a spore from a fungus which passes through the sheep, and then that spore begins to grow, I guess you would call it. The fungus grows and then basically parasitizes the larva. So I think that's pretty neat, and being able to reduce the parasite load on the pasture.
So I did my first FAMACHA training about 22 years ago at the Katahdin Hair Sheep, the 3rd annual Katahdin Hair Sheep meeting when it was in Maine. So I think FAMACHA is one of those things. I think that hands down one of the biggest things that has reduced parasite problems, and particularly in the Southeast, is the switch to using breeds that are more parasite resistant, and then the selection intensity that has gone along with that. If you look at the level of resistance in the animals and how it's progressed over the last 20 years of selection, it's really phenomenal. So The nice thing that we're also seeing with that is that those sheep that are more parasite resistant are also more disease resistant. And that's some of the work that's kind of been coming out of our lab recently. So I think that that's been a nice thing that we've been able to identify for sheep, and is kind of leading the way with other livestock species in identifying healthier animals or animals that are more immune competent.
So that immune system really is the key there to that, to promoting those sheep that are resistant to both parasites and to the diseases.
Correct. So what we're seeing is that parasite resistant sheep, so we've done a divergent selection model of Katahdin sheep for 8 or 9 years with our colleagues down at Virginia Tech. And they've got Katahdin sheep that are very susceptible to parasites and Katahdin sheep that are very resistant. And by raising those animals in the same environment, we're able to look at how that similar environment affects both of those genotypes differently. So we see that lambs that are more parasite resistant survive better to weaning, and that having nothing to do with parasitism, not parasite loss. That is pneumonia, foot rot, you name it, Clostridium type A, a lot of different diseases that sheep are just set up to find a way to kill themselves, right? So sheep are born to find a way to kill themselves. So that's what they do. And these parasite resistant sheep tend to find that at a lower rate. The other thing that we found with this is that dams, so these parasite resistant dams, generate about 2.5 times the amount of antibody in their colostrum than the parasite susceptible dams. So that part of it may be contributing to the survivability of those lambs up and through weaning. We've got just a lot of work that shows that the lambs respond better to vaccinations. So we get a better antibody response out of the lambs, out of the parasite resistant lambs to common vaccines. So when we're selecting for parasite resistance and using fecal A counts to do that, we are also selecting for immune response as well.
That's really fascinating, Scott. And I would wonder, with a more robust immune response, will this increase some of the nutrient requirements for those animals? You know, when you think about how nutrient heavy the requirement is to support an active immune response. And it also, I wonder if this goes back to maybe some of the nutritional factors of the dam during pregnancy relative to fetal programming and
Sure.
so on.
So all the dams in these situations are treated equivalently, right? So they're all vaccinated, they're all done that way. I think that sometimes we may overestimate the amount of nutrition and an immune response cost, because we usually think about it in an animal who's already sick, right? So
Yeah.
then bringing them back up to a maintenance level is a big differentiation. I think that it costs more to put on a pound of protein than it does to generate an immune response, or to put on a pound of muscle. So in that case, I think it's negligible, the amount of nutrition that is going to be necessary to support that. I think that if you're feeding and supplementing lambs and expecting any kind of growth rate on pasture, you're going to be supplementing effectively to satisfy gain and any kind of nutritional requirements from the immune response.
I like the conversation that we got going on, and so I'd like to just extend it a little bit. Scott, would you mind? And I know you do tons of research on this topic specifically. Would you mind just elaborating more about the research that you're doing? Specifically, I heard more about that artificial parasite research that you're doing, correct?
No, so they're real parasites. It it's the animals aren't getting a natural infection. So my
Okay.
background goes. I'm more of an immunologist and a sheep producer than than what should be normal. But nonetheless, that's where we start with all of that stuff, is trying to understand how some sheep are generating a better immune response to a parasitic infection, right? So when I started at WVU, we just started going at very early stages of infection. And when you do that, there's no way to quantify the infection level in the animals without slaughtering them, right? So you've got to slaughter them at we did it at 3, 5, and 7 days post-infection. And then we went out to even like 10 days a little bit later. And we were trying to understand immune mechanisms that are being activated in parasite resistant sheep versus susceptible sheep. And basically, it boils down to a couple of big things. Number one, St. Croix sheep, which are, I would put them up against any parasite resistant sheep anywhere in the US or in the world for that matter, generate a rapid and robust immune response that is complemented by cells, antibody, cytokines, and a variety of different things. But realistically, the big things that we found was that the parasite resistant sheep respond to the larval stage of the parasite, where the susceptible sheep seem not to. They're almost immunologically blind to it. So that was the one thing. So there's a persistent delay in the response of Suffolk sheep, and those are our susceptible model for this. There's a persistent delay in the initiation of an immune response in those animals. Then we started thinking about how to do this with Katahdin sheep, and that prompted us to start looking at divergent mating in the Katahdin group. And we started that back in 2016, 2015, 2016. And what we found, what one of my first students found with that was the death loss differences. And the first year we did that, we just did sire. So we took a group of Katahdin ewes, we randomly assigned them to either 3 really parasite resistant sires, meaning that their fecal A count breeding value was less than -75. And then on the positive side, they had to be as high as possible. I didn't think that we would find sheep that were +50s or higher that were alive and people were still using. When we started, we had +600, +500 rams. So we had a big divergence in those mating groups. The first year that we did this, we had a 30% death loss in the high fecal A count sired rams, so the ones with the high EBVs, compared to a 10% death loss in the negative sired lambs. So that in and of itself, and the fact that none of that came from the death loss that we saw there was coming from parasitism. Well, sorry, gastrointestinal nematode parasitism. Could have been coccidia, but it was more often than not, it was either clostridial disease, particularly that year, and then pneumonia. So that year in Southwest Virginia, they had a large breakout of Clostridium type A, and we weren't vaccinating for that. So we had a 20% difference in death loss the first year. The next year we had, I think, about 7 or 8% death loss. And every year since then, and even now with our divergent mating system being both on the sire and dam side, we're consistently at about a 10% difference in death loss across those genotypes annually. So if you consider that over the last few years, we have marketed more lambs off of one breeding group than we have off the other. So there's that part of it. And then we started diving into how do you measure general immune competence? And I think that's really difficult to think about or try to find one assay that's going to do that. So we took a really simplistic approach to that to start with and saying, okay, let's just measure antibody response to a vaccination. So we'll get blood samples on lambs when we give them their first Clostridium vaccination, and then when we give them their booster, and then follow that for a few weeks out. And then the lambs that were more parasite resistant generated a lot more antibody than the ones that were parasite susceptible, right? So then we started thinking about, okay, how do we mimic a bacterial infection in these animals? And we started looking at their response to lipopolysaccharide, which is a component of gram-negative bacteria cell walls. And we found that parasite-resistant sheep develop a temperature, but resolve the temperature in about 6 hours. Suffolk sheep, it takes them about 12 hours to resolve the temperature. And there's a lot of differences that are going on, which have prompted us to kind of think about how do we how do we utilize all of this information? And I think one of the best things that come from this is an idea that somebody dropped on me a few years ago. What's the algebra of a zero fecal A count? What does a zero mean? If you're a geneticist in Nebraska and somebody's sending you phenotypes on animals and they have a zero, does that mean that they're parasite resistant? Or does it mean that none of the animals were infected and everybody has a zero? Or that you got a fecal sample from somebody in northern Michigan in January and their fecal A counts were zero? Well, what do you expect? So there's all of this stuff that's going on where we don't know what a zero really means unless the population, unless a group of sheep have a significant infection already. But with antibody and response to antibody or response to a vaccine, antibody is never zero. It's never bottomed out. So what we can actually do is look at a response to this. So what my group is working on now is trying to collect enough phenotypes on sheep across the country where we can start developing an antibody breeding value or an antibody response breeding value that can be coupled with the fecal A count breeding value to generate a health index for sheep. So that kind of gives you an overview of the last 14 years.
I think you made one point that stuck out in my mind is that even within a breed that we expect to be parasite resistant, there is a lot of variation. So I know as I'm working out in the field with producers, they'll tell me, well, I'm buying this breed of sheep because they're parasite resistant. And I think that just kind of hits home the fact that they're not going to remain parasite resistant unless you continue to make that selection to keep sheep that are resistant, that you can see a lot of variation.
The funny thing about that, Melanie, is when we were doing this LPS project, we had a pin full of St. Croix sheep, and St. Croix sheep went into making Katahdins. So we had a pin of St. Croix, then we had a pin of low EBV. So this at the average EBV of this group of ewe lambs was -88. Then we had a pin of high breeding value ewe lambs, Katahdin ewe lambs. Their average breeding value was +288. And then we had a group of Suffolks. And if you stood back and look at it, and just the livestock evaluation part comes out every now and then, and just look at the groups, what you saw was a continuum of hair to wool. So you had all of these sheep that were really hairy, right? With the St. Croix, the low fecal A count breeding value Katahdins, a little bit more wool, but mostly hair, had that same kind of phenotype that we'd see with the St. Croix. And as we moved to the right, where those other sheep were, we started to see more wool. And it could have been just an aberration or just a random selection of these sheep, but I think that what happens over time is that you get some genetic drift that occurs in selection criteria, because if you don't maintain pressure on that, you'll drift to the traits that are more heritable, and you're going to get more growth and muscling and those kind of things as you start, and even crossbreeding that occurs within Katahdin sheep. So you're 100% right that there's a ton of variation within breed variation, as almost as much as there would be with between breed variation. So
perfect. Well, that was really interesting. I have never delved into your research that deeply, so that was very, very informative for me, and I really enjoyed that. Thank you so much. Since we're coming to sort of the end of this recording session, I'd like to do a little bit of a fun question. And I don't know if this would be classified as fun, but for me, it'll be fun. But so for you guys, each of you, what parasite do you guys find the most interesting in general? However you want to classify that, but you can take a few minutes to think about it. But
mine's pretty simple. I'm fascinated on how successful parasites are and how they have adapted their life cycle. So I'm intrigued by those parasites that have really complex life cycles. So like toxoplasmosis, or even the meningeal worm in terms of its larval migration and how it gets to the brain and so on. I just when I teach parasitology, it's just phenomenal to I always try and find some recent news clip of a new parasite or a unique scenario of a parasite to essentially gross out the students, in terms of thinking about those things.
I think the hypobiosis kind of intrigues me, where these parasites go into dormancy through certain times of the year, and then all of a sudden they recognize when it's going to be an ideal time for them to complete their life cycles, and then pass all these eggs out in the feces. So I think that amazes me that this little itty bitty parasite can figure that out so that it can continue its life cycle.
So my parasite, and I don't remember the name of this parasite, but it has this really unique life cycle. Its definitive host is a seabird, and the intermediate host for this is fish. So when fish are consuming fecal material of this bird, the parasite enters the fish and it affects their flight and fight response. So instead of when they see shadows, instead of hiding, they make themselves basically they present themselves to a bird to be eaten. So it affects their brain, so the worm can be back into its definitive host, right? So they've developed, if you think about this and just the evolution of all of this stuff and how this stuff, and that's just change over time, how this stuff has developed over time is amazing, right? And how the host, and I look at it from both ways, right? You have this really cool parasite, but then you have this host that's developed to either deal with it, right? Accept a low level of it and survive just fine, or completely succumb to it. So I think of it both from the host and the parasite side of it, and that's one of my examples I use in parasitology class that I teach, of different migration patterns or using definitive and intermediate host. And I can't for the life of me remember the name of the parasite right now, but it'll come to me here in a little bit.
That was so cool. I love hearing everybody's different opinions and things like that. So, just to wrap up, is there any last words or thoughts that we didn't cover that you would like to share with the audience or with the group or anything?
I would just remind folks that there's a lot of resources that are available to them, both online and within their own states. The American Consortium for Small Ruminant Parasite Control at wormx.info has a plethora of information on there. One of the key features of that program is the low-cost fecal egg counting service. That was a program that was set up by us, Virginia Tech, LSU, Texas A&M. We all will do fecal egg counts for right around $5 to $7 per sample. We do about 5,000 fecals a year for people outside of our system. So that's it's a really good program. It's a really good a way to get those done inexpensively. I think most vets are going to charge, your local vet's going to charge you $20 to $30 per sample on that. We're doing that quite a bit cheaper. And then also doing the FAMACHA training. So finding those FAMACHA trainings that are available, and that website posts a lot of those that are available nationwide.
Dr. Van Son, one of our other colleagues, and I are doing a fecal egg counting workshop. So we have that planned for August 23rd up at the university. So this is a great way for folks to kind of get their feet wet and looking at what it takes to do their own fecal egg counts. Some of them may go on to do their own, and others may realize it's easier for sending a sample off to a veterinarian or even down to WVU to get them analyzed.
It's kind of like a sharing school, right? Most people learn that they either want to do it or they want to send it off and have somebody else do it.
I had one last question. Dr. Ray Kaplan, before he retired, had developed that drench right test in terms of sending samples down and being able to identify anthelmintic resistance and so on. I understand that test some of the components of that test had come from Australia or something, and then during COVID that supply chain was lost. I thought Louisiana State University was going to take over this, but I haven't heard anything. Is that test going to be available again? And again, I really reinforce the WormX information. I use that tremendously.
Yeah. Adriano Vata at LSU has been doing that, and I think that he's still trying to get some of those components in. They're still doing a few of them at Georgia. There's some other people that work with Dr. Kaplan while he was there. So like Sue Howell and Bob Story, those guys are still down there doing some of that stuff. So I think they're trying to migrate that whole test over to LSU, but I don't know where they're at in that pipeline. One of the things that I do is I just use clear dewormers and a 96 well plate. And if you can, I just use oxfenbendazole and just do a simple dilution and just look at some parasite motility with that. As you go through different serial dilutions, it's not as formalized as what Ray has done with the drench rite assay, but if you want to get a sense of where your flock is at, it's pretty simple to do that as well.
Sweet. Well, if nobody has anything for the betterment of the group, I think we can end this recording session. So thank you guys so much for coming on and being a part of the Barnyard broadcast.
Thanks, Maddie.
Thanks,
You're
Maddie.
welcome,
Well, I certainly enjoyed that conversation, and I thank all guests for being on the podcast and sharing their unique experiences and immense knowledge. If you would like any more information about parasites, please visit extension.psu.edu or wormx.info for more information. As always, you can also reach out to your local livestock educator for more information. Thank you for listening, and I will see you on June 4th for our next episode.